In today's video, I will be trying to synthesize some nitrogen triiodide and to see how powerful its detonation is. Nitrogen triiodide is a highly sensitive contact explosive, and it is made using ammonium hydroxide and iodine. Warning: toxic chemicals were used in this demonstration. Nitrogen triiodide is highly unstable and can detonate unexpectedly. Handle only with proper PPE, ventilation, and full safety precautions. Disposal or detonation should be performed only in controlled environments by knowledgeable individuals. Nitrogen triiodide is one of the most unstable compounds ever made. There are three large iodine atoms that are forced around a tiny nitrogen atom that create an extreme steric strain that stretches and weakens the chemical bonds. This leaves the compound with an incredibly low energy barrier to decomposition, so even the slightest touch, vibration, or disturbance around it may cause it to violently break apart into nitrogen gas and iodine vapor. This reaction produces a loud, sharp snap and a distinctive purple cloud of iodine. This compound is a reddish black crystalline solid that has absolutely zero industrial or commercial use, as it's highly unstable and is only used in demonstrations and for fun. Now that you know a little bit about the compound, let's try and attempt to synthesize it. To get started, first we'll weigh out approximately 1 gram of iodine. Now, as you can see, I've collected about 1.7 grams of iodine, which will correspond to approximately zero point 0.0 grams of nitrogen triiodide. Now that we have our 1 gram of iodine, it is now time to add the ammonium hydroxide. For this demo, I'll be using a 27% solution, and I'll be using around 20 milliliters of the liquid. If you are wondering why I'm using a plastic cup, it is because although nitrogen triiodide is less sensitive when wet, it can still detonate, and it is better for it to detonate in a plastic cup than in a glass beaker that can shrapnelize and hit people around you. After about 15 minutes of waiting, the liquid has become a black, dark red liquid. Now, our nitrogen triiodide is in precipitate, so we do not have to worry about separating it. We can just simply filter it using a filter paper and a funnel. To begin our filtration, I'll just take a plastic bottle, the funnel, and the filter paper, and I'll just put the liquid through the filter paper. Now, I came across a problem that the nitrogen triiodide did stay stuck to the cup, so off camera I just scraped it off with a spoon and put it into the filter paper. After about 10 minutes, we are left with a black solid and a yellow liquid, which is most likely some iodine dissolved in water, and our black solid being our nitrogen triiodide. After the filtration was complete, I moved my setup to a more ventilated area, set up a hot plate, and then I took the filter paper with the nitrogen triiodide and I opened it up. After that, with my thumb, I flattened out the solids for a more even drying. Although this did kind of react, it wasn't the nice explosion or detonation that I was looking for, so something went wrong, and I believe that it was too wet, so for the next experiment I tried to dry it even more. For the next run I have approximately 1.5 grams of nitrogen triiodide. Here you can see that there's way more of the black powder, and I used stones to weigh the paper so that it doesn't fly away. Now, this reaction kind of did the same thing as the last one. It fizzled, but it did have a nice pop, like that right there, but it didn't fully detonate all at once like I wanted to. So clearly this was still wet, and I still needed to find a way to get rid of the water, so clearly I need to dry it for longer, and that's exactly what I did for the next step. For the next run, I am still using 1.5 grams of nitrogen triiodide, but I'll be drying it for a longer period of time, which will hopefully dry it enough so that it can detonate all at once. But here came the second problem I ran into. Now, you can already see that the bulk of the powder is missing and that it looks way wetter than it was before. And so what I think happened was that As it slowly dried in the natural environment, it would slowly decompose where the wetter parts of the solid would still remain, which is what I have now, but the drier parts that we want are disappearing, are decomposing back into iodine and nitrogen. So, how can I work around this? Well, I thought I would use a method where instead of just letting the waterlogged solids dry in the air, I would use a method where after the filtration was complete, I would also pour isopropyl alcohol over the powder so that the water gets separated from the powders, leaving isopropyl alcohol to inhibit the space. And then once it's drying, since isopropyl alcohol evaporates way quicker and is more volatile than water, it would evaporate, leaving a more drier powder in the end after a short period of time. Now, off the bat, this powder already looks way more promising than every other powder as it's drier and it hasn't lost a significant amount of mass. But let's see if we put some heat on it, will it detonate like I want it to, or will it just sizzle like every other one so far? Wow, that really worked. That exploded and detonated way faster than every other one and didn't just sizzle. Now, don't let this clip fool you because in person it was much more loud and much more frightening than in the video. Here I have the filter paper that was used to hold the solids. You can see that it thoroughly destroyed the parts of the paper that it was on, even though it was only 1.5 grams, which really makes it scary and really makes you wonder how much more violent and how much more scary the detonation would be if you scaled up the amount to 10 grams or even 100 grams. And the coolest part about this, as you can see, the faint but beautiful purple clouds of iodine that was produced in the detonation. I always thought that this was very beautiful, and it is amazing how something this beautiful could be that scary.